Hello everyone, today we will be solving bitwise XOR of all pairings. The question says you are given two zero-index arrays nums1 and nums2 consisting of non-negative integers. There exists another array nums3 which contains the bitwise XOR of all the pairings of integers between nums1 and nums2. Every integer in nums1 is paired with every integer in nums2 exactly once. Return the bitwise XOR of all the integers in nums3. So we have two arrays nums1 and nums2. And num3 is not given to us, but it is defined as the bitwise. It is defined as an array which consists of bitwise XOR of all the pairings. So for example, we have 3 elements in nums1 and 4 elements in nums2. Then num3 will have 12 elements, which will be this, this, and this, and there will be this, this, and this. And we have to take the XOR of all these elements. 1, 2, 3 and 4. So this is what num3 will contain. So what we have to tell in the question is the bitwise XOR of all the elements in num3. So let's just say that we have A, B, C in nums1 and D, E, F, G in nums2. If we see what nums3 is, it will be A XOR D, A XOR E, A XOR F, A XOR G, and similarly for B. So we can see that when we are doing the bitwise XOR of all the elements in num3, we will have the bitwise XOR of all these elements. So this would be nothing but D XOR E XOR F XOR G. This happens because the length of nums2 is even. So all the elements that we are pairing from nums1 will get cancelled because they will be occurring an even number of times, and if an element occurs an even number of times, the bitwise XOR of that element will be 0 because A XOR A is 0. So if this is even, this will also be 0. So what we will have is just this array. And similarly, this would happen for B and C. So we would just have D XOR E XOR F XOR G for B and D XOR E XOR F XOR G for C. So as we can see that they are occurring, and this entire quantity is occurring and even number of times. So the final answer would be D XOR E XOR F XOR G. So we can consider another example where we have maybe um, since we have considered odd and even, let's just consider even and even. So we'll have this. So if we just take a XOR, we'll have XOR P XOR D and P XOR E. So we can see that if we take the XOR, it will just be 0. So if nums1 has an odd length and nums2 has an even length, before that let's consider XOR 1 to be the bitwise XOR of all the elements from 1 to n for nums1, and similarly XOR 2 is the bitwise XOR of all the elements for nums1, and this is 2. Fine. So if this is the case, nums1 and nums2, the answer would be, if this is odd and this is even, so hmm, so the answer would be XOR 2, and if this is even and this is odd, the answer would be XOR 1, and if this is odd and this is odd, then the answer would be XOR 1 XOR XOR 2, and if this is even and this is even, the answer would be 0. So there are only 4 cases for this problem, and we can accordingly do it. So define XOR. 1 0, 2 0, XOR 1 would be 20. Similarly, XOR 2 would be this. Then we'll say C, mm, and D equals so D equals A modulo 2 and B modulo 2. We just return XOR 1, XOR 2. That's it. A modulo 2 and B modulo 2 double equals 0. That would mean that we will return XOR 2. So if A modulo 2 double equals 0 and B modulo 2, then we just return XOR 1. Else we just return XOR 0. That's it. Thank you.